let's look at one last problem here. Let's look at G. In G, we have, let's see, negative e to the x minus 1 plus 2. So we have two different shiftings and something else also entirely going on. Well, first of all, the minus 1 that's inside of the exponent here is going to shift us left or right. In this case, remember a minus 1, the x's, we do the reverse because it's on the inside. We're going to shift it to the right one. The plus 2 on the outside, however, is going to shift us up or down. That's going to shift us specifically up 2. And we're not even going to touch this yet. We'll deal with this minus sign at the end. Okay. Well, the first thing that we have to worry about is our asymptote. Our asymptote normally starts at 0. Well, the shifting it left or right won't matter. However, the shifting it up or down will. So we're going to shift that asymptote up 2, means the asymptote won't be at 0 anymore. It will be at 2. The other thing we have to worry about is our point, which was at 0, 1. Now, both shiftings will matter here. The first thing that we're going to do is shift it to the right one. Then we're going to shift it up 2. And where that lands us is here at this point, right here, to the right one and up 2, puts us at 1, 3. That is our first point that's really actually special there. Remember, I do want to find 1 point on either side, which means I'm going to want to plug in 0 on the left side of 1 and 2 on the left side of 1 and see what happens there. But first of all, I do have to take care of this negative sign before I do that. What will the negative sign do? The negative sign is actually going to flip us upside down. What does it flip us upside down over? It flips us upside down over our horizontal asymptote here. So if I was 1 point above the horizontal asymptote, when I flip it upside down, it's going to flip me to being 1 point below the asymptote in the same spot. Now I'll plug in my 0 and my 2 to my function, see what happens, and that will give me my points on the other side. So let's plug in 0 first. Plugging in 0, let's see, 4x will give me, let's see, plugging in 0 will give me negative e to the, well, 0 minus 1 will give me negative 1 plus 2. Well, e to the negative 1, that's about 1 over e. And making it negative, it's about negative, it's about negative 1. Let's see what that does. Well, 1 over e is 2.7. And then making that negative would be negative 0.37. Added to your 2 would give us about 1.6-ish. So that means if I plug in 0, I get about 1.6, which is a little bit smaller than 2. A little bit smaller than that asymptote there at 2. Now let's see what happens if I plug in 2. We get negative e to the, well, if we're plugging in 2 now, for x, it'd be 2 minus 1, which is 1, plus 2. Well, again, I need to think about this because e to the first power here is 2.7, but the minus sign will make that negative. And then I still have to do what? I still have to add the 2 to it, which will give me about negative 0.7. So let's plot that point, which is 2, comma, let's see, negative 0.7. and to negatives here. So 2, negative 0.7. So, and following along through our 3 points to make our exponential graph. So normally, had we had our exponential graph with the e, it would have been an increasing graph going through the point above. But what the negative did, we can see, is it flipped that negative, took this graph, and flipped it upside down over the horizontal asymptote, and just took that picture and just flipped it upside down and made a mirror image. So our final graph, let me go ahead and make clear, is this red graph here. It goes through the 3 points here and has actually been flipped over and is upside down over the horizontal asymptote at 2. That is our final graph. Next, let's look at solving